A chemical company poisoned an entire bay in Japan. They knew about it, they hid it, and for 12 years the people who lived there kept eating the fish. The mercury they discharged entered the food chain at the microscopic level and moved upward, through plankton, through fish, through shellfish, concentrating at every step. By the time it reached the fishing families of Minamata, the doses were lethal. Children were born with permanent neurological damage. Adults lost the ability to walk, speak, and see. The company's own doctor confirmed the link in 1957 and was ordered to stay silent. The case took 17 years to reach a court. It took 60 years to produce an international treaty signed by 140 governments. This is the full story, from the first discharge to the last courtroom. Minamata is a coastal city in Kumamoto Prefecture on the southwestern island of Kyushu, Japan. In the early 1950s, it functions as a working fishing community, structured entirely around daily access to the bay. The bay itself is not large. It is sheltered, shallow in parts, and enclosed by a narrow mouth that opens into the Shiranui Sea. These conditions produce a productive marine environment. Fish and shellfish accumulate in predictable patterns. Families organize their schedules around tides and seasonal migration routes. The catch feeds the town directly and supports local trade. This dependence on the bay is not incidental, it is structural. Fishing is not supplementary income, it is the primary food source and economic base for a significant portion of Minamata's population. The relationship between the community and the water is daily, physical, and total. Operating directly on the shoreline of the same bay is the Chisso Corporation chemical plant. Chisso has maintained an industrial presence in Minamata since 1908. By the early 1950s, the plant produces acetaldehyde, a compound used in the manufacture of plastics, pharmaceuticals, and industrial solvents. Acetaldehyde synthesis at this facility uses inorganic mercury as a catalyst. The production process generates mercury-containing wastewater as a byproduct. That wastewater is discharged, without advanced treatment, through effluent channels, directly into Minamata Bay. The volume of discharge is consistent. The chemical composition of the wastewater includes inorganic mercury compounds. What occurs within the bay's sediment and water column, however, is not immediately visible. The first anomalies are behavioral. Cats living near the shoreline begin to exhibit progressive motor dysfunction. Municipal records and later court documents describe the phenomenon in consistent terms. Animals losing coordination, moving in irregular circles, falling into the water. Local residents refer to it as cat dancing disease. The cats are not isolated cases. The pattern is geographically concentrated, in communities closest to the bay's edge. Seabirds exhibit similar disorientation. Fish are reported surfacing abnormally or washing ashore. The marine ecosystem, which had been stable and productive, begins registering visible disturbance. Fishermen note changes in catch behavior. These observations are informal at this stage, pass between households, not yet entering health or environmental records. The mechanism behind these changes is not yet identified. What is known at this point in time is the input: continuous industrial discharge into a shallow, semi-enclosed body of water with limited exchange flow. The bay does not flush rapidly. Compounds that enter the water column tend to accumulate in the sediment. Organisms living in or feeding on that sediment are exposed continuously. Bioaccumulation is the governing process. Microscopic organisms absorb dissolved compounds from the water. Small fish consume large quantities of those organisms. Larger fish, shellfish, and marine mammals then consume the smaller fish. At each stage, the concentration of retained compounds increases. The final consumers in this chain, the cats, the birds, the fishing families, receive the highest accumulated dose. This is not a localized spill or a discrete incident. It is a continuous input into a closed system, sustained across years of operation. The discharge records for this period exist. The plant's effluent outputs were monitored internally. The chemical composition of Chisso's wastewater was a known quantity within the company's own operational data. The gap between what those records contained and what was communicated to municipal or prefectural health authorities reflects a documented pattern of non-disclosure, not an absence of information. By the mid-1950s, the bay that fed Minamata is changing in ways that residents can observe but not yet explain. The cats are dying, the birds are falling, the fish behavior is shifting. The plant on the shoreline continues operating on the same schedule. What follows is not an accident of ignorance. It is a sequence of decisions, each traceable in the record. On April 21, 1956, a 5-year-old girl is brought to the Chisso Corporation's company hospital in Minamata. She cannot walk without assistance. Her speech is severely impaired. Her limbs move in irregular, uncontrolled patterns. Within days, her younger sister presents with identical symptoms. Dr. Hajime Hosokawa is the director of that hospital. He examines both children and finds no explanation within standard diagnostic categories. He does not record an isolated case, he records a pattern. On May 1, 1956, Hosokawa formally notifies the Minamata City health authorities of an unknown neurological condition affecting multiple patients. That notification marks the official entry of the disease into the public health record. Municipal health registries begin documenting the cluster. The cases share a defined symptom profile. Motor dysfunction is consistent across patients: loss of coordination, difficulty walking, involuntary limb movement. Sensory disruption is also documented. Patients report numbness in the extremities, difficulty seeing, and reduced sensitivity to touch and temperature. Speech impairment appears across multiple cases. In the most severe presentations, patients lose the ability to control basic physical functions entirely. The Minamata City investigation team begins a geographic mapping of cases. The distribution is not random. Cases concentrate in households close to the bay, specifically in fishing communities with direct and regular access to local seafood. Inland households, without that pattern of consumption, do not appear in the registry at the same rate. The spatial data is clear from an early stage. The cluster is attached to the shoreline. At this point, no confirmed cause is identified. The condition is classified as an unknown infectious or toxic disease of the central nervous system. Investigators consider multiple hypotheses: a contagious pathogen, a nutritional deficiency, a locally specific toxic exposure. Each hypothesis is tested against the available case data. The infectious disease hypothesis does not hold. Affected individuals share geography and diet, not direct interpersonal contact. The disease does not spread laterally between people living in proximity without shared food sources. Health workers who treat patients directly do not develop symptoms. The epidemiological profile eliminates person-to-person transmission relatively early in the investigation. The dietary hypothesis gains traction. The consistent factor across affected households is consumption of fish and shellfish from Minamata Bay. The Minamata City investigation identifies this correlation within weeks of the initial notification. It appears in early municipal health records. Fishing communities dependent on bay-sourced food are overrepresented in the case registry by a margin that cannot be attributed to chance. The response to this finding is a public advisory. Residents near the bay are informed that a health investigation is underway. However, no formal restriction on bay fishing or seafood consumption is implemented at this stage. The catch continues. The diet continues. New cases continue to appear in the registry through the second half of 1956. Hosokawa does not limit his investigation to the hospital. He initiates internal research at the Chisso facility to examine whether the plant's discharge might be connected to what he is observing clinically. His position as hospital director within a company-owned facility places him inside a structural conflict. The investigation he begins is legitimate, but the institution that employs him has a direct operational stake in its outcome. By the end of 1956, the Minamata City Health Registry has recorded more than 50 formally documented cases. The number reflects confirmed diagnoses, not the full scope of affected individuals. Households where symptoms were mild, or where families concealed illness due to social concern, are not fully captured in this count. The documented figure is a lower bound. The geographic concentration of cases adjacent to the discharge point of the Chisso plant is visible in the registry data from the first months of documentation. That correlation exists in the municipal record. It is not a retrospective inference. Health investigators observe it in 1956. Prefectural authorities receive the early case reports. The data indicating a relationship between proximity to the bay and neurological disease is present in official documents before the cause is confirmed. Institutional awareness of an emerging health crisis and institutional response to that crisis do not move at the same speed. The documentation precedes the action. That gap is measurable. The disease has a name by this point. Locally, residents call it Minamata disease. It does not yet have a confirmed mechanism, but it has a geography, a symptom profile, a demographic pattern, and a growing case count. All of it is in the record. The cause is still formally unknown. The data needed to find it is already accumulating. The Chisso plant's acetaldehyde production process uses mercuric sulfate as a catalyst. The reaction converts acetylene and water into acetaldehyde through a series of controlled chemical steps. Inorganic mercury is introduced into this process as a functional industrial input, not as a waste product by design, but as an operational requirement. What exits the reaction chamber, however, is not only acetaldehyde. The wastewater generated by this process contains residual mercury compounds. Among them is a specific organomercury compound, methylmercury chloride. Its formation occurs within the reaction environment itself. Certain chemical conditions present during acetaldehyde synthesis, temperature, pH, and the presence of organic intermediates, facilitate the attachment of a methyl group to inorganic mercury. The result is methylmercury. It is more stable than inorganic mercury in biological systems. It crosses cellular membranes with high efficiency, and it discharges into Minamata Bay through the plant's effluent channels continuously, across years of operation. Methylmercury enters the water column as a dissolved compound. It does not disperse uniformly. In the shallow, semi-enclosed geometry of Minamata Bay, where water exchange with the open sea is limited, the compound accumulates in the sediment layer. Anaerobic bacteria in the sediment interact with inorganic mercury as well, independently converting it to methylmercury through a separate biological pathway. The bay's own sediment becomes a secondary source of the compound, compounding the initial industrial input. The biological uptake begins at the base of the marine food web. Phytoplankton and microscopic organisms absorb methylmercury directly from the water column through passive diffusion across cell membranes. The compound does not pass through easily. It binds to sulfur-containing proteins within the cell. This binding is the key to its persistence. Unlike many environmental compounds, methylmercury is not metabolized or excreted rapidly by biological tissue. It is retained. The concentration within each organism exceeds the concentration in the surrounding water by a measurable factor. Zooplankton consume phytoplankton in large quantities. Each feeding event transfers accumulated methylmercury upward. Because zooplankton consume volume far exceeding their own body mass over time, and because the compound is retained rather than eliminated, the concentration in zooplankton tissue is substantially higher than in phytoplankton. This process is biomagnification, the increase in concentration at each successive trophic level. Small fish feed on zooplankton continuously. The same retention mechanism operates at this stage. The fish does not excrete methylmercury at a rate that keeps pace with ingestion. The compound binds preferentially to muscle tissue and neurological proteins. A small fish living and feeding in Minamata Bay accumulates methylmercury across its entire lifespan. The longer the lifespan and the higher the feeding rate, the greater the tissue concentration at the time of harvest. Larger predatory fish and shellfish occupy the next level. Shellfish are particularly significant in this chain. Filter feeders such as clams and oysters process large volumes of water continuously, retaining particulate and dissolved compounds at high efficiency. Toxicology literature documents shellfish tissue concentrations of methylmercury substantially exceeding those found in the surrounding water column, by factors of several thousand in heavily contaminated environments. These organisms are sessile. They do not move away from the contamination source. They accumulate across their full residence time in the bay. The human exposure pathway is direct and repetitive. Fishing families in Minamata consume bay-sourced seafood as a primary dietary staple, not occasionally, but as the dominant protein source across daily meals. Municipal health records and later court documents confirm that affected households consumed fish and shellfish from the bay multiple times per day in many cases. Each meal delivers a dose of methylmercury proportional to the tissue concentration of the consumed species. The dose accumulates in human tissue by the same mechanism operating at every lower level of the chain. Methylmercury in the human body crosses two critical barriers with particular efficiency: the blood-brain barrier and the placental barrier. Once inside the central nervous system, it binds to neurological proteins and disrupts cellular function in the cerebellum, the visual cortex, and the sensory processing regions of the brain. The symptom profile documented in Minamata's health registries, motor dysfunction, sensory disruption, speech impairment, visual field narrowing, maps directly onto the neurological regions where methylmercury causes documented tissue damage. This correspondence is not coincidental. It is mechanistic. The pathway from discharge pipe to human neurological tissue is continuous, chemically coherent, and fully traceable through environmental and biological systems. Each step is governed by documented chemical and physiological processes. No single link in the chain requires inference. The mechanism exists in the toxicology literature independently of the Minamata case. What the Minamata case provides is a large-scale, long-duration, real environment instance of that mechanism operating on a human population. The chain is invisible only in the sense that it cannot be seen without instrumentation. In the documented record, it is precise. By 1956, Dr. Hajime Hosokawa is operating in a structurally unusual position. He is the director of a hospital owned and funded by the Chisso Corporation, the same corporation whose plant discharge he is beginning to investigate as a potential cause of the neurological cases he is documenting clinically. His research access is internal. His findings go to company management. The institutional pathway between his laboratory and the public health record runs directly through Chisso's corporate structure. Hosokawa initiates animal experiments in 1957. The central question is specific. Can the symptoms observed in Minamata patients be reproduced by controlled exposure to Chisso's industrial wastewater? The experimental model is cats. The choice is deliberate. Cats in the fishing communities surrounding the bay had exhibited the same neurological deterioration as the human cases: motor dysfunction, disorientation, loss of coordinated movement. If the same symptoms could be induced in a controlled laboratory setting using plant effluent, the causal link between the discharge and the disease would have experimental support. The experiments produce a clear result. Cats fed directly on fish taken from Minamata Bay and cats administered Chisso plant wastewater under controlled conditions develop progressive neurological symptoms consistent with those observed in human patients. Motor dysfunction appears first. Coordination deteriorates. In advanced cases, the animals lose autonomous physical function entirely. The symptom progression in the experimental animals matches the clinical progression documented in the municipal health registry. Hosokawa's internal records document this correspondence explicitly. These findings are compiled into internal reports submitted to Chisso management. The reports exist. They are dated. They establish that by 1957, 1 year after the formal notification of an unknown disease to Minamata City health authorities, Chisso's own research arm had produced experimental evidence linking plant discharge to neurological disease in a controlled setting. The results are not disclosed to public health authorities. They are not submitted to the Kumamoto prefectural government. They are not published in medical or toxicology literature. They remain within the company's internal document structure. In 1958, Hosokawa's investigation continues. He refines the experimental protocol and attempts to isolate the specific compound within the wastewater responsible for the neurological effects. His internal work is moving toward identifying methylmercury as the causative agent through biological evidence, independent of and concurrent with the academic research being conducted at Kumamoto University at the same time. Internal company documents indicate that Hosokawa's experimental findings are reported upward within Chisso's management hierarchy as the research progresses. Also in 1958, Chisso makes an operational change to its discharge pathway. The plant redirects its effluent outlet from Hyakken Harbor, the primary discharge point, into Minamata Bay to the Minamata River. The stated rationale for this change is not documented in public records as an explicit acknowledgement of contamination risk. However, the timing is precise. The redirection occurs while Hosokawa's internal research is active, and while the public association between bay contamination and neurological disease is becoming more visible in the community. The effect of this change is to distribute mercury-containing discharge across a wider geographic area, introducing contamination into the river system and affecting communities upstream of the original discharge zone. New cases begin appearing in villages beyond the initial cluster. The spatial expansion of the disease follows the new discharge pathway. In 1959, Chisso installs a wastewater treatment system at the plant. The system, a cyclator unit, is described internally and publicly as a measure to address water quality concerns. Independent analysis and subsequent court records establish that the cyclator does not effectively remove methylmercury from the effluent. Discharge of mercury-containing wastewater continues after installation. The installation functions, in the documented record, as a visible operational response that does not resolve the underlying emission problem. It is presented to municipal authorities and the public as a remediation measure. The same year, Chisso reaches a financial agreement with the Minamata Fishermen's Cooperative. The agreement provides compensation payments to affected fishing households. Critically, the agreement's language designates the payments as consolation money, not as acknowledgement of liability. A clause within the agreement states explicitly that if Chisso is subsequently found to be the cause of the disease, the company is not required to make additional payments. Affected families, many of whom lacked independent legal counsel, signed the agreement under economic pressure. Court records later examine this document in detail. Throughout this period, Chisso's public position maintains that the cause of Minamata disease is not confirmed, that the company's discharge has not been established as the source. This position is stated to prefectural authorities, to the national government, and in public communications. It is stated while internal documents record experimental confirmation of the link. It is stated while Hosokawa's research sits in the company's own files. The internal scientific record and the external institutional communication describe two different states of knowledge. Both are documented. The distance between them is not a product of scientific uncertainty. It is a product of disclosure decisions made within the corporate structure, with full awareness of what the internal record contained. That is the precise definition of concealment in the documentary and legal record of this case. In 1958, the geographic boundary of documented Minamata disease begins to move. The initial case cluster concentrated in fishing households immediately adjacent to Minamata Bay. That concentration had a clear spatial logic. The communities closest to the primary discharge zone, consuming the highest volumes of locally caught seafood, presented the earliest and most severe cases. Municipal health registries for 1956 and 1957 reflect this pattern consistently. The disease in those records has a defined center. By 1958, cases are appearing at the edges of that center, and then beyond it. Fishing villages along the Shiranui Sea coastline, outside the immediate boundary of Minamata Bay, begin reporting neurological symptoms consistent with the documented clinical profile. Motor dysfunction, sensory disruption, and speech impairment appear in households that had not previously entered the registry. The Kumamoto Prefectural Health Administration begins receiving case reports from municipalities that had not been part of the original investigation zone. The mechanism driving this expansion is the same one that produced the initial cluster. Chisso's 1958 effluent redirection, from Hyakin Harbor to the Minamata River, introduces mercury-containing discharge into a connected waterway with broader geographic reach. The river system distributes the compound along its course. Marine organisms in adjacent coastal zones accumulate methylmercury through the same bioaccumulation pathway documented in the bay. Fishing families in villages along that coastline consume the same categories of seafood from the same connected marine environment. The exposure pathway extends with the discharge pathway. The spatial expansion is not uniform. It follows the water. Prefectural health records from this period document new case registrations in communities separated from Minamata by distances of several kilometers. The symptom profiles match those already classified. The dietary histories of newly registered patients confirm regular consumption of seafood from the Shiranui Sea coastal zone. The geographic distribution of cases, mapped against fishing activity and coastline proximity, produces a coherent environmental pattern in the registry data. Then, the registry records something that changes the clinical understanding of the disease entirely. Among the new cases documented from 1958 onward are infants. Newborns and young children in affected fishing communities present with severe congenital neurological damage. The presentations include cerebral palsy-like motor dysfunction, profound intellectual impairment, seizure disorders, and sensory deficits present from birth. These children have not consumed bay fish independently. They have not had direct environmental exposure through diet. Their neurological damage is not acquired. It is developmental. The explanation lies in the placental barrier. As established in the mechanistic record, methylmercury crosses the placental barrier with high efficiency. Mothers who consume contaminated seafood during pregnancy transfer methylmercury to the developing fetus through normal placental circulation. Fetal neurological tissue is substantially more vulnerable to methylmercury toxicity than adult tissue. The developing brain, in active cellular organization during gestation, sustains damage at exposure levels that may produce only moderate symptoms in the mother. Clinical documentation from this period records cases where mothers show mild or no apparent neurological impairment, while their newborns present with severe, permanent neurological damage. This pattern carries a specific evidential weight. Congenital cases eliminate occupational exposure as a confounding variable entirely. The affected infants have no independent dietary history, no workplace exposure, no behavioral risk factor. Their only shared characteristic with the adult cases is maternal consumption of seafood from the contaminated zone during gestation. The congenital cases are, in epidemiological terms, the clearest possible signal of environmental transmission through a biological pathway. Municipal and prefectural health registries expand to accommodate the new case categories. The classification system for Minamata disease is revised to include congenital presentations as a formally documented subtype. Court records produced in subsequent legal proceedings reference these registry expansions in detail. They establish both the chronology of recognition and the institutional awareness of congenital harm as a documented outcome. By 1960, the total number of formally registered cases across all affected municipalities has grown substantially beyond the initial 1956 cluster. The registered figure remains a lower bound. Social stigma attached to affected families, documented in community records and later sociological research, suppresses reporting in households where concealment of illness is judged preferable to registration. Families in fishing communities face economic consequences from public association with the disease. The actual affected population exceeds the documented one by an unquantifiable margin. The disease is no longer a localized incident. It is a regional environmental health event with a documented spatial distribution, a confirmed transmission pathway operating across 2 generations, and a case registry that continues to expand with each reporting cycle. The widening of the circle in the registry data is not epidemiological uncertainty. It is precision. Each new case location, each congenital presentation, each village report adds a data point to a spatial pattern that has only one coherent explanation. The discharge source remains active throughout this entire period. The circle widens because the input continues. In 1956, Kumamoto University establishes a formal research team to investigate the unknown neurological disease appearing in Minamata's health registries. The team is multidisciplinary, drawing on internal medicine, neurology, pathology, and biochemistry. Its mandate is to identify the causative agent through systematic clinical and environmental analysis. The investigation is independent of Chisso Corporation and operates outside the company's institutional structure. That independence becomes significant. The research team's early work focuses on the symptom profile. Clinical examination of registered patients produces consistent neurological findings: damage to the cerebellum, the sensory cortex, and the visual processing regions of the brain. The pattern of tissue damage is specific. It does not correspond to known infectious diseases, nutritional deficiencies, or genetic conditions in the existing medical literature. It does correspond, with precision, to the documented neurological effects of heavy metal poisoning, particularly organomercury compounds. By 1957, the Kumamoto University team formally identifies organic mercury as the probable causative agent of Minamata disease. This conclusion is reached through convergent evidence: the neurological damage profile, the geographic and dietary distribution of cases, environmental sampling from the bay, and tissue analysis from affected patients and animals. The hypothesis is not speculative. It is grounded in clinical data, environmental chemistry, and established toxicology. The findings are submitted for publication. Academic toxicology and medical literature begin carrying the Kumamoto research from the late 1950s onward. The publication record is datable and specific. The scientific community outside Minamata begins receiving documented evidence that an organomercury compound, originating from an industrial source, is producing large-scale neurological harm in a defined human population. In 1959, the research team moves from organic mercury as a category to a specific compound. Methylmercury is identified as the agent responsible for the observed pattern of toxicity. This identification is supported by the chemical analysis of patient tissue samples, environmental samples from the bay sediment and water column, and the experimental reproduction of the disease's neurological damage profile in laboratory animals exposed to methylmercury under controlled conditions. The Kumamoto findings are consistent with and independently confirm the experimental results that Dr. Hosokawa had produced internally at Chisso's own hospital, results that remained inside the company's document structure. The scientific case, by 1959, is documented, published, and independently reproducible. The institutional response does not follow the same trajectory. Chisso Corporation formally challenges the Kumamoto University conclusions. The company disputes the identification of its discharge as the source of methylmercury contamination and contests the causal chain between plant effluent and patient outcomes. Alternative hypotheses are proposed and actively promoted. One hypothesis attributes the disease to explosive residues deposited in the bay during the Second World War, suggesting that legacy munitions, not ongoing industrial discharge, were responsible for the contamination. Another hypothesis implicates amine compounds rather than mercury as the causative agent. These alternatives are examined against the available evidence. Neither holds under scrutiny. The explosive residue hypothesis does not account for the temporal correlation between Chisso's production increases in the early 1950s and the onset of disease cases. It does not explain the congenital presentations, the animal behavior patterns, or the specific neurological damage profile documented clinically. The amine hypothesis similarly fails to correspond to the tissue damage pattern or the environmental distribution of the compound. Toxicology literature does not support either alternative as consistent with the full body of observed evidence. The alternatives are nonetheless formally entered into regulatory and governmental deliberations. Their function in the institutional record is measurable. Each unresolved hypothesis extends the period during which a confirmed regulatory response can be deferred. Uncertainty, even when manufactured against the weight of existing evidence, creates procedural space. That space has a duration. It is the interval between scientific identification and institutional action. And during that interval, discharge continues and cases accumulate. The national government's response is categorized in the documented record as delayed. The Ministry of International Trade and Industry, which holds regulatory authority over Chisso's industrial operations, does not move to restrict discharge on the basis of the Kumamoto findings in 1959. A government-affiliated research committee examining the causation question produces findings broadly consistent with the university research, and those findings are not immediately translated into regulatory action either. The structure of the delay is not scientific. By 1959, the causative agent is identified, the exposure pathway is documented, the case registry is expanding, and congenital harm is formally recorded. The scientific basis for regulatory intervention exists in published, peer-reviewed form. What does not exist at this stage is an institutional decision to act on that basis. Scientific consensus and institutional acceptance are not the same process. They do not operate on the same timeline. In the Minamata record, the gap between them is precisely dated and populated on one side by documented evidence and on the other by documented inaction. The research continues. The discharge continues. The Municipal Health Registry does not stop growing. Through the late 1950s and into the 1960s, new case registrations continue at a rate that outpaces any institutional response directed at the source. Each registry entry represents a formal clinical diagnosis a patient examined, a symptom profile recorded, a household added to the documented count. The registry is a minimum figure. Reporting gaps produced by social pressure, geographic isolation, and deliberate concealment within affected families mean the documented total understates the actual affected population by a margin that cannot be precisely calculated from available records. The clinical classification of Minamata disease becomes more defined as the case volume increases. Neurologists working with the Kumamoto University research team and municipal health authorities develop a formal diagnostic framework. Cases are classified by severity across a spectrum. Mild cases present with persistent sensory disruption, numbness in the extremities, narrowing of the visual field, reduced sensitivity to temperature and touch. Moderate cases add motor dysfunction, unsteady gait, difficulty with coordinated hand movements, tremor. Severe cases involve the progressive loss of voluntary movement, speech, swallowing function, and consciousness. At the extreme end of the documented range, complete physical incapacitation is recorded before death. The congenital category, formally recognized in the registry from the late 1950s onward, carries its own classification structure. Affected children present across a range of developmental outcomes: cerebral palsy-like motor impairment, severe intellectual disability, seizure disorders. Clinical records document children who never acquire the capacity for independent movement or communication. These outcomes are permanent. Methylmercury damage to the developing nervous system is not reversible through any treatment available during this period or since. The economic structure of the fishing communities begins to deteriorate in parallel with the health registry's expansion. Contamination awareness reaches the wider regional and national market by the late 1950s. Fish and shellfish from Minamata and the surrounding Shiranui Sea coastal zone carry an association with the disease in trade networks and public perception. Buyers reduce purchases. Market prices for Minamata-origin seafood decline. Fishing households that had structured their entire economic activity around bay access find that the market for their catch contracts at the same time that the physical productivity of the bay is diminishing under ongoing contamination. The structural vulnerability here is specific. These communities had no significant economic alternative to fishing. The bay was not a supplementary income source. It was the income source, the food source, and the organizational basis of daily life. When the bay becomes both a health threat and an economically compromised resource simultaneously, the community has no fallback position. Savings are limited. Alternative employment in the Minamata area is concentrated in the Chisso plant itself, the institution responsible for the contamination. The economic dependency that made the bay so central to community survival is the same dependency that makes contamination of the bay catastrophically damaging. Fishing activity formally declines as prefectural advisories regarding contamination become more explicit through the early 1960s. Some households cease bay fishing voluntarily upon receiving health information. Others continue, because stopping means losing the only food and income source available to them, and because the disease's relationship to seafood consumption, while increasingly clear in the scientific literature, is communicated inconsistently to affected communities by authorities. The decision to continue fishing in documented contamination conditions is not irrational given the economic structure these families inhabit. It is a constrained choice made under conditions of institutional information failure. Social stigma compounds the material damage. Affected families report discrimination in community settings, in schools, and in marriage negotiations. In Japanese social structures of this period, disease, particularly neurological disease with visible physical manifestations, carries significant stigma. Families with registered cases face social exclusion that operates independently of their economic situation. Children of affected parents encounter discrimination in educational settings. Families conceal diagnoses to avoid these consequences, which simultaneously reduces the registry count and isolates affected individuals from available support structures. Stigma also attaches to the fishing identity itself. As Minamata disease becomes nationally known, residents of affected communities report being identified and avoided in contexts outside Minamata. The geographic origin of a person becomes a social liability. The community's relationship to the bay, historically a source of identity and livelihood, becomes a source of exclusion in the broader social environment. Court documents produced in subsequent legal proceedings record testimony from affected families describing these conditions in detail. The testimony establishes that the harm experienced by Minamata communities extends well beyond the clinical registry. Health damage, economic collapse, and social exclusion operate simultaneously and reinforce each other. A family managing a member with severe neurological impairment simultaneously loses fishing income, faces reduced market access, and navigates social discrimination, without institutional support structures adequate to the scale of the combined impact. The human toll of Minamata disease is not singular. It is layered across biological, economic, and social systems, each layer interacting with the others, each one traceable to the same originating input. The discharge continues through this entire period. The toll accumulates in direct proportion to its duration. On June 14, 1969, a group of families affected by Minamata disease files a civil lawsuit against Chisso Corporation in the Kumamoto District Court. The plaintiffs are fishing households, patients with severe neurological impairment, families of those who have died, and parents of children with congenital damage. They are not the first to seek compensation from Chisso. They are the first to reject the company's settlement framework entirely and pursue judicial determination of liability through formal court proceedings. The decision to litigate is a structural departure from the compensation model that Chisso had managed since 1959. The consolation agreements signed by fishing cooperative members in that year had explicitly excluded future liability claims. Many affected families had accepted those payments under economic duress and without independent legal representation. The 1969 plaintiffs refused that framework. They file for damages on the basis of negligence, arguing that Chisso knew its discharge was harmful, that it concealed that knowledge, and that it continued discharging mercury-containing wastewater into Minamata Bay across the full period during which the harm accumulated. The court proceedings opened the documentary record in a manner that the compensation framework had not. Industrial discharge records from the Chisso plant are entered into evidence. The records establish the volume, composition, and duration of effluent discharge from the acetaldehyde production process. They document the continuous nature of the discharge across the period from the early 1950s through the cessation of mercury-using acetaldehyde production in 1968. The timeline in the discharge records is precise and datable. Internal company documents are also examined. Among the most significant is the documentation of Dr. Hosokawa's animal experiments conducted at Chisso's own hospital in 1957 and onward. These records establish that Chisso's internal research arm produced experimental confirmation of the link between plant discharge and neurological disease, and that this confirmation was reported to company management and not disclosed to public health authorities or the court's predecessor regulatory bodies. Hosokawa himself, by this point gravely ill, provides a deposition before his death in 1970. His testimony confirms the internal research findings and their non-disclosure. It enters the court record as direct witness evidence from inside the company's own institutional structure. The scientific record compiled by Kumamoto University is presented in full. The identification of methylmercury as the causative agent, the documentation of the exposure pathway, the clinical classification framework, and the epidemiological analysis of case distribution are all entered as evidence. The court examines this material against the chronology of Chisso's internal knowledge, establishing the temporal relationship between what the company knew, when it knew it, and what it communicated externally during the same periods. The defense arguments center on the state of scientific certainty at various points in the chronology. Chisso's legal position maintains that causal confirmation was not definitively established until the scientific literature reached consensus, and that the company's actions prior to that consensus cannot be judged by standards of knowledge that were not yet formally settled. The court examines this argument against the internal document record. The argument that external scientific uncertainty excuses corporate inaction does not hold when internal documents demonstrate that the company possessed affirmative evidence of harm before external consensus was reached. The Kumamoto District Court delivers its ruling on March 20, 1973. The court finds Chisso Corporation liable for the neurological harm caused by its discharge of methylmercury-containing wastewater into Minamata Bay. The ruling is grounded in the negligence standard, establishing that Chisso failed in its duty of care to prevent foreseeable harm to identifiable populations who depended on the bay for their livelihood and sustenance. The court determines that this failure is not attributable to scientific ignorance. It is attributable to a documented pattern of decisions, to continue discharge, to suppress internal findings, to propose alternative hypotheses, and to structure compensation agreements in ways that foreclosed future liability claims. The damages awarded to plaintiffs are substantial. The ruling covers surviving patients with severe neurological impairment, families of deceased patients, and families of children with congenital damage. The compensation framework established by the court is differentiated by severity of harm, producing a classification-based damages structure that the subsequent administrative certification process for Minamata disease draws upon directly. The legal standard articulated in the 1973 ruling carries implications beyond the immediate case. The court establishes that an industrial operator bears responsibility for foreseeable environmental harm caused by its discharge, regardless of whether that harm was acknowledged publicly at the time. The existence of internal knowledge, documented in company records, is treated as establishing the foreseeability standard. The ruling does not require proof that Chisso intended harm. It requires proof that Chisso possessed information indicating harm was occurring and chose not to act on that information. That standard is met by the documentary record. The 1973 ruling is not the end of legal proceedings related to Minamata disease. Certification disputes, additional plaintiff groups, and government liability claims continue through subsequent decades. But the Kumamoto District Court judgment establishes the foundational legal determination: corporate liability, grounded in documented concealment, producing enforceable accountability under civil law. The internal record that Chisso constructed across 17 years of operation becomes, in 1973, the primary instrument of its own legal accountability. Japan's national regulatory framework for environmental protection does not exist in any coherent form during the years when Minamata disease develops, expands, and accumulates its documented toll. Industrial discharge in the 1950s operates under a legal environment that prioritizes economic production. There is no national legislation establishing enforceable limits on industrial effluent composition. There is no unified oversight body with authority to compel operational changes at a facility like Chisso's Minamata plant on public health grounds. The absence of that framework is not incidental to the Minamata case. It is a structural condition that the case exposes with precision. The legislative response begins taking shape before the 1973 court ruling, driven in part by Minamata and in part by concurrent pollution crises emerging elsewhere in Japan during the same period. The 1960s produced 3 additional major industrial pollution cases in Japan that enter public and political consciousness alongside Minamata. Itai disease in Toyama Prefecture, caused by cadmium discharge from mining operations. Yokkaichi asthma in Mie Prefecture, caused by sulfur dioxide emissions from a petrochemical complex. And a second outbreak of organic mercury poisoning in Niigata Prefecture, caused by discharge from a different chemical plant using the same acetaldehyde production process as Chisso. The Niigata case, identified formally in 1965, is particularly significant. It demonstrates that the Minamata outcome is not unique to one location or one company. It is reproducible under the same industrial conditions, which means it is a systemic regulatory failure, not a local anomaly. The convergence of these cases creates political conditions for legislative action that the Minamata case alone had not produced. In 1967, Japan enacts the Basic Law for Environmental Pollution Control. The legislation represents the first national statutory framework explicitly addressing industrial environmental harm as a category requiring systematic legal regulation. The law establishes the state's responsibility to protect public health from pollution, a principle that had not been formally codified in Japanese law during the period when Minamata disease was developing. It defines pollution across categories including water, air, soil, noise, and ground subsidence. It creates a legal basis for government intervention in industrial operations on environmental grounds. The 1967 law is followed by a sequence of more specific regulatory instruments. The Water Pollution Control Law, enacted in 1970, establishes enforceable discharge standards for industrial effluent entering water bodies. It requires monitoring, reporting, and compliance, and it gives regulatory authorities the legal standing to impose operational restrictions on facilities exceeding defined limits. Mercury discharge receives specific regulatory attention within this framework. The categories of compounds subject to control are drawn directly from the documented evidence base of the pollution cases, Minamata prominent among them. 1970 is a significant legislative year in this sequence. The Japanese parliament convenes what becomes known as the Pollution Diet, a legislative session dedicated to environmental law reform. 14 pieces of pollution-related legislation are enacted or substantially revised during this session. The speed and volume of legislative output reflects the accumulated political pressure of cases that had been developing, and in some instances, killing and disabling people for over a decade, while regulatory instruments remained inadequate. Government oversight structures are expanded alongside the new legislative framework. The Environment Agency is established in 1971 as a dedicated national body with authority over environmental policy, monitoring, and enforcement. Prior to this, environmental oversight had been distributed across ministries whose primary mandates were economic development and industrial management, an arrangement that placed the regulatory function inside institutional structures with competing priorities. The creation of a dedicated environmental authority represents a structural separation of environmental protection from industrial promotion at the national administrative level. The Minamata case enters the regulatory reform record not only as a catalyst, but as an evidentiary foundation. The documented pathway from industrial discharge to environmental contamination to human harm, established through court proceedings, academic research, health registry data, and internal corporate documents, provides the empirical basis for specific regulatory provisions. Mercury discharge limits, effluent monitoring requirements, and environmental health surveillance protocols in the new legislative framework are calibrated against what the Minamata evidence demonstrates is possible when those controls are absent. Government liability in the Minamata case is also examined through the legal and political process of this period. The Ministry of International Trade and Industry had received information about the disease's probable industrial cause as early as 1959 and had not acted to restrict Chisso's discharge. The prefectural government of Kumamoto had received expanding case registry data across the same period. Subsequent legal proceedings brought against the national and prefectural governments by Minamata disease patients argue that regulatory inaction in the presence of documented evidence constitutes a form of governmental negligence. Japanese courts examined these claims across multiple proceedings, extending into the 1990s and beyond. The findings in those cases extend the accountability framework established in 1973 into the public sector. The certification process for Minamata disease patients becomes its own source of sustained institutional failure. The administrative system established to identify and compensate recognized patients applies diagnostic criteria that health researchers and patient advocates consistently argue are too narrow. Thousands of applicants are rejected under criteria that exclude presentations outside the most severe clinical classifications. The certification dispute continues for decades, producing a secondary layer of institutional harm imposed on populations already damaged by the primary event. The regulatory aftermath of Minamata disease is therefore not a clean resolution. It is a layered process in which legislative reform, administrative failure, continued legal proceedings, and incomplete compensation operate simultaneously across multiple decades. The framework that should have existed before 1956 is constructed, partially and imperfectly, in the years after 1967. Its construction is driven by evidence that accumulated, at great human cost, in the absence of any such framework. What the Minamata record contributes to that construction is irreplaceable. It is the largest and most thoroughly documented case of industrial mercury poisoning in the historical record. And it exists in that form precisely because it was allowed to continue long enough to generate a complete body of evidence. The Minamata case does not end in 1973. The court ruling of that year establishes corporate liability within Japanese civil law, but the disease's patient population continues expanding through subsequent decades. Administrative certification disputes produce new legal proceedings into the 1990s. Additional plaintiff groups file against both Chisso Corporation and the Japanese government. The final government-mediated settlement between the Japanese state and remaining uncertified patients is reached in 2009, 53 years after Dr. Hosokawa's initial notification to Minamata City health authorities in 1956. That duration is itself a data point in the regulatory record. It measures the interval between the formal identification of industrial harm and the completion of institutional accountability for that harm. The global dimension of the Minamata case rests on a specific chemical fact. Mercury is not a locally contained industrial input. It is a globally distributed element that enters atmospheric, aquatic, and terrestrial systems through industrial emissions, artisanal mining, coal combustion, and chemical manufacturing processes operating across multiple continents simultaneously. The pathway from industrial mercury use to human neurological harm, documented in Minamata across 2 decades of clinical, environmental, and legal evidence, operates wherever the exposure conditions are reproduced. The World Health Organization produces exposure guidelines for methylmercury in food, calibrated substantially against the clinical and toxicological evidence base generated by the Minamata research. Pregnant women and developing fetuses receive specific guidelines reflecting the congenital harm documented in Minamata's registry from the late 1950s onward. The United Nations Environment Program begins formal assessment of global mercury pollution in the early 2000s, drawing on epidemiological data from multiple continents, and establishing that mercury contamination requires a coordinated international regulatory response, not manageable through national legislation alone. Negotiations for a binding international treaty begin formally in 2010 under UNEP auspices. 140 national delegations participate across 5 sessions of intergovernmental negotiation. The resulting treaty is adopted on October 10, 2013, in Kumamoto, Japan, the same prefecture where Minamata disease was first formally reported. The location is deliberate. The treaty is named the Minamata Convention on Mercury. The convention enters into force in 2017. Its provisions address the full life cycle of mercury, from primary mining through manufacturing use, emissions, and final disposal. Specific articles prohibit new mercury mines, phase out mercury use in defined product categories, require best available techniques for emissions control in industrial sectors, and mandate national action plans for artisanal gold mining. The naming of the convention after Minamata is not ceremonial. It is a specific attribution of precedent. The treaty's preamble references the Minamata disease experience as the foundational documentation of mercury's harm to human health. Every signatory government formally acknowledges, within its national legal record, that the Minamata case established the evidentiary basis for the obligations it is undertaking. The chain of causation runs from a discharge pipe on the shoreline of Minamata Bay to a treaty signed by the majority of the world's governments 60 years later. That chain is traceable at every link. The discharge records exist. The clinical registries exist. The internal corporate documents exist. The court findings exist. The scientific literature exists. The treaty text exists. No part of the sequence requires inference. It is a complete documentary record of how industrial activity, inadequately regulated, produces harm, and of how that harm, adequately documented, produces accountability. The bay at Minamata has undergone remediation. Contaminated sediment was dredged and contained between 1977 and 1990. Mercury concentrations in marine organisms within the bay have declined to levels that Japanese authorities consider acceptable under current regulatory standards. What is not contained is the record. It remains a complete account of decisions made, harm produced, knowledge suppressed, and accountability delayed. Its completeness is the direct result of how long it was allowed to continue, and that completeness is now the legal and scientific foundation of an international standard bearing the name of the bay where it began.